We will be testing the intelligence and speed of the new Bonsai 26B 1-bit model on a 3066 GB laptop GPU. We will also compare it to Gemma 426B, which I tested on the 3060 with a consistent 30 tokens per second. We will be using the latest llama.cpp to test the Bonsai model and compare the results for the same prompt in the Gemma 4 app online to see if it is worth switching to this model locally. You can download the Bonsai model from the Prism ML official Hugging Face account. You should download the main Q1 model for inference and also mproj Q8 for image inputs. And if you need faster tokens at no quality loss at the expense of 2 GB of VRAM, then you should also download the DSpark Q4 model. I tested the DSpark model with the latest llama.cpp and it is still not supported, so we will only test the main model and its vision capabilities. First, download the model and place it in the same folder as the llama.cpp CLI. Because it is a 1-bit model, it can fully fit in VRAM, just taking 4 GB of VRAM. Let's get started in conversation mode with Q4 quantized cache in all layers in the GPU. Let's start with a prompt having a spelling mistake and asking it to provide simple short answers. This will test how much the model needs to think for simple answers. The prompt is, tell me Pythagoras theorem formula, don't explain. As you can see, it gave us the exact formula without any explanation, like what is A, B, and C, just like how we wanted. And you can clearly see its thought process, how it uses so much language to think things through and make sure it doesn't make a mistake. It took 10 seconds just to answer such a direct query, at 33 tokens per second generation. Gemma 4, on the other hand, spent very little time in thinking and quickly gave me the correct same answer. It took only 6 seconds despite having 27 tokens per second, but that was because the laptop was thermal throttling at the time because of continuous other prompt testing. Okay, let's ask a further question to convert this formula into a Python function. Write a simple Python function to return C when we give A and B as arguments, don't explain. It gave us the answer, but look how many tokens it used. It used 872 tokens just to give such a simple Python function, and took 27 seconds. You can read its thought process, that it is considering not using the math module and debating whether it should use it or not, and self-doubting even after the final check. So it is trying very hard to follow prompt direction. But local models are not supposed to be used for heavy complex coding anyway. Speed is much more important for such simple problems. Also, it doesn't matter if its tokens per second is 32. If it is taking so much time thinking to write such a simple function, then it is not worth using it locally. Compare this to the Gemma answer. It only took 12 seconds. It is still very long, but that is because the model wasn't fully on the GPU. So even at a disadvantage, the Gemma model is more performant even if you don't have much VRAM. And this too had 32 tokens per second and only took 337 tokens, compared to 872 of the Bonsai model. Okay, let's move to a slightly more thinking question. What if A and B are part of a complex number A plus IB? Then what does A squared plus B squared represent, and how it relates to polar coordinates in the complex plane? This has a straightforward answer, but I am just seeing how it structures the answer. Okay, it gave us the answer, took 28 seconds, 32 tokens per second, and used 888 tokens. The final answer it gave is very concise and perfect. It mentions the Euler formula. It correctly gives the answer that Euler formula. It correctly gives the answer that A squared plus B squared is the magnitude of the complex number, and how A and B relates to the polar angle theta. So the quality is perfect and the time it took is reasonable but not great. Gemma also gave the correct answer, but it was very thorough and the structure was very good for someone who actually wants to follow the steps in more detail. I prefer the Bonsai answer because it was able to summarize the answer neatly, so in case some other LM requires the answer from this model. Context wouldn't be wasted, but Gemma takes time to explain what these terms are, mentions the Argand diagram, also mentions the Euler formula, and gives just a perfect one-sentence summary of the answer. Overall, I would say I would rely on Gemma more than I would on Bonsai for general coding or text-related stuff. More testing is required. That is my first impression. Let us test its vision capabilities. First, let's check the density of detail it can capture by giving it a Wikipedia article with fine font, and then ask it to write a Python function to compare if two multi-line strings are equal or not. I just made a multi-line string of repeating sentences to see if it hallucinates repeating the same sentences over and over in OCR. The prompt is, give exact OCR text of the given image, don't explain. It gave such a long response, so much time in thinking, parsing the exact text from the image and thinking, and also in the final result. Input tokens were 936, and it took almost 2 minutes and 3,500 tokens for just OCR. Its output contained weird stats because of verbosity. But I did this just to see how much token and time it takes. Now we have an idea that it takes too much time and tokens. So from a speed perspective, it is not good. But let's see for its accuracy. Let's run this prompt again without verbosity. Okay, the answer looks good. Let's ask it to make a Python function for comparison to see how coding is after 4K tokens of not relevant information. The prompt is, write a Python function to compare if two multi-line strings are equal or not. Also give arguments for when line breaks don't matter and when character case doesn't matter. Okay, it gave an answer, and it is as I suspected. This is totally not usable for local coding. Look how much thinking there is. It took so long, even though tokens per second is 29, but because chain of thought reasoning is so aggressive even for such a simple function, I don't know how anyone can use this for local coding. The architecture is great, and I have high expectations from this company, but the training data, or the base model Quen they are using, is just not right for the task. Let's see if the code and OCR data it generated is good or not. Okay, I tested the exact match for the main original text from which the image was made, and the output Bonsai made, and used its function to compare strings. In the end, I removed all spaces, line breaks, and character case to see if the correct character order is there or not, and it failed in all of them, so detailed OCR is not working, and I expect it. Let's see if Gemma 4 can do this. I will use the online Gemma 4 app for this. Same prompt, give exact OCR text of the given image, don't explain. Okay, Gemma gave the answer, and my credits ended, so I won't be generating the Python function. But let's use the Bonsai function to check if it passes. Okay, it also failed, and it is also expected. Now I use a correct sequence matcher function to output how much both strings match, so we can check which gave a better answer. Okay, I tested both, and they both are pretty much 99% accurate, so that is great. Now, the actual image reasoning and parsing test. The prompt is, see the image, identify subjects, and for each subject, briefly explain the image icon along with listing the components making it. Okay, the answer it gave is very good and correctly explains the image in detail. You can read it if you want. Now let's check the same prompt with Gemma. The answer got cut off in the middle, but the description is just bad. It didn't even mention the apple in the maths icon. Overall, for images, I am very impressed by Bonsai, and might actually use it if it wasn't for such a long thinking portion. Let's try this again, but limiting the thinking budget to only 100 tokens. You can do that by setting reasoning budget to 100, and after doing that, it stops the thinking via the chat template end thinking tag, but doesn't stop thinking in the final output as it uses the thinking chain of thoughts text in the final answer. So it did generate the correct answer, but took 85 seconds for it and 2,564 tokens for it. So, not worth it. Overall, my impression of the Bonsai is that it is good for general text reasoning related stuff, parsing, summarizing, OCR, and very good at image summary. But the main problem is too much thinking, so because of that, it is not usable for me at least. Gemma is still a better option. It doesn't spend an eternity thinking, and you can actually control the thinking budget more reliably. If you want to run Gemma 27B on a 3066 GB GPU, then watch this video.